So if everyone can confirm you can see the screen right now?
It's a little dark.
Yes, see it very well.
Once I play, it'll become bright.
Today we're going to talk about the central role of nitric oxide in functional medicine outcomes. I am Beth Shirley, and I am a compounding pharmacist and a certified clinical nutritionist. So why is nitric oxide essential? It regulates all cardiovascular function and homeostasis, circulation and microcirculation, which means nitric oxide touches every single cell. It's critical to sexual function, the vasodilation, and innervates erectile tissue in men and women. The red blood cells require adequate nitric oxide in order to deliver the oxygen to the cells. Supports neurotransmitter function, regulates the gastrointestinal function, including gastroparesis, the mucus layer, the circulation to absorb the nutrients, helps activate the GLUT4 receptor in order to translocate and bring glucose into the cell. It controls the efficiency of the mitochondria in the generation of energy and the generation of hormones. Pregnenolone's metabolism starts in the mitochondria. It's required for stem cell mobilization and differentiation. Regulates the immune system function, regulates the inflammatory response, and scavenges free radicals. Modifies platelet activation and aggregation. This is a clotting issue. And supports telomerase activity and this has everything to do with longevity. So how do we make nitric oxide? We've got two different pathways. The first pathway, the arginine-NOS pathway, oxidizes arginine and oxygen through the NOS enzyme to make nitric oxide. And finally, it oxidizes into nitrate and nitrite. And then we've got the nitrate pathway. So we've got the nitrate and nitrite from the arginine pathway, plus whatever we get in our diet or supplementation. The nitrate is swallowed, so it goes into the circulation, gets concentrated in the salivary gland. The salivary glands release the nitrate, and we've got good anaerobic bacteria on the dorsal aspect of our tongue that has nitrite reductase capacity. So these bacteria will reduce that nitrate to nitrite. The nitrite is swallowed in the acidic environment of the stomach. Some of the nitrite is reduced further to nitric oxide, but most of the nitrite is absorbed, circulates around, and we have different nitrite reductases in tissue to make nitric oxide on an as-needed basis. Hypoxia stimulates these nitrite reductases as well as acidity. So as we age, our ability to make nitric oxide through that eNOS pathway decreases. And with the first graph, you can see that as women